Hey guys, good evening. Yes, can you hear me? Hello. Yes, guys, can you hear me? Yeah, thank you. Yes, let me check. Yes, I hope everyone, yeah, everyone is online only. Fine. So well and good. So let us start session. So previous class. Yes, yesterday's class. One second. Yes, what is software? Like system software, application software. Yes, about OS. Next. Yes, here front ends, back ends, languages and packages. Next, low level languages, high level languages. Next, generation of languages. Yes, these things were discussed after this completed topic. Okay, the basics, just the basic discussed. Okay. Yes, today we'll discuss about interpreter and compiler. Yes, after finishing, then entering into Java features. Okay, so then entering into Java features. Okay, yes, to understand these Java features here, yes, first of all, we'll see about what is interpreter and compiler. Yes, about interpreter. Yes, interpreter and compiler is very important topic here. Yes, every software engineer must have this knowledge. Every software engineer must have interpreter and compiler. So this knowledge must be required. Okay. Yes, see, the guys who are having 10 years of experience also they can't answer properly. Yes, the guys who are having 10 years experience also, they can't answer properly here. So exactly what is compiler and interpreter? Exactly what is compiler and interpreter? Let us see. Yes, here high level language and low level language. High level and low level. High level language. High level language like Java program or C program. Yes, all those are high level language. Java program like English language. Java program is like English language. Okay. See, for example, here Java program. Suppose some Java program. Suppose here some Java program. See this. This is some Java program, right? Yes, like looking like English language. This is called as high level language. Yes, it's a high level language. It's a high level language. One more example here. Python. Let us take Python. Yes, Python. Suppose Python scripter. Python scripter. Yes, see this. This are like a English language. This are like English language. Okay. Yes. So one more example. Suppose HTML. HTML. Suppose HTML codes. HTML codes. HTML. HTML. See this. These are like English language. So all are English language. Okay. So this is called as high level language. Yeah, this code is a high level language. This code is a high level language. It's a user understandable language. But system can't understand this language. System cannot understand this language. Okay. System can't understand this language. Okay. System cannot understand this language. Okay. Yet this language, this every high level language instruction. One second. Some guy facing some issue. Joining here. One second. Yes. See if anyone, yes, unable to. If anyone unable to hear me, here please rejoin the session. Please rejoin. Just rejoin. Rejoin the session. Rejoin the session. Yes, rejoin the session. Okay. Yes. This girl, I think Sri Devi, somebody is there. Okay. Has to resign. Resign. Okay. Yes. If anyone unable to hear me, please rejoin the session. Okay. Next, one more. Right. Yes. And yes, Chirag. This guy, Chirag Kumar has to resign. Yes, these two have to resign. Okay, these two have to resign. These guys have to resign. Okay, yes, have to resign. Yes, these guys have to resign. Okay, yes. Yes, if anyone unable to hear me, please raise hand in the session. Yes, yes, these guys are in offline. They are in offline. They are in offline. They are in offline. They're in offline. Yes, they have to resign. They have to resign. Okay. Yes. Okay, fine. Yes. See here, high level, low level language. See here, Java program. 1 second. Yes, Java program. Here, this is high level language. Java program. Yes, high level language. Yes, suppose Python script is a high level language. Yes, suppose HTML. It's a high level language. These are high level language. Yes, computer cannot understand this language. Yes, all these language has to convert. All of these things have to convert into, yes, have to convert into binary codes. Have to convert into binary codes. Who will convert this? For this, either compiler, yes, either compiler or interpreter. Either compiler or interpreter or interpreter. Yes, either compiler or interpreter here. Either compiler or interpreter. Okay. Yes, either compiler or interpreter. Okay. Seek either compiler or interpreter. Okay. Will convert from high level language to binary code. Compiler or interpreter. Okay. Compiler or interpreter. Yes, to convert from, yes, high level language means like English language. That English language. High level language. Yes, high level language. Yes, high level language. Yes, high level language to low level language means binary code. That's bandicoot. Okay, bandicoot. Seek a compiler or interpreter. Yes, to convert. Compiler or interpreter to convert from high level language. High level. Yes, high level language to bandicoot. High level language to bandicoot. High level language to bandicoot. Zeros ones format. Seek a compiler and interpreter. Compiler, interpreter. Yes, either compiler, interpreter. Yes, both are converting from high level language to Bytecode. Both are doing same job, but the way it's working is different. Okay, compiler, interpreter, the way it's working is different. Both are to convert from high level language to binary code. Both are to convert from high level language to binary code, but the way it's working is different here. The way it's working is different. Let us see. Yes, here interpreter versus compiler. Let us see this. What's the difference between these two here? Okay. Yes, interpreter. Yes, interpreter versus compiler. Yes, our topic is interpreter versus compiler. Interpreter versus compiler. Interpreter versus compiler. Okay. Yes, interpreter versus compiler. First, let us take interpreter. Interpreter. Yes, interpreter based language. For example, here. Yes, test.py. Some Python script. I'm taking some Python script. Test.py. Test.py. Okay, yes, it's a source code. Interpreter working on source code. So source code is some test.py. Okay, some test.py. Test.py Python code. Just I'm taking Python. Python is a interpreter based language. So I'm taking Python. 1 second. Yes, Python. Yes, in my documents. D drive. Yes, mn Python folder. Yes, this all Python, some examples are there. Yes, D drive. Get command prompts. See here, exit, closing that. See command prompts. CMD, command prompts. CMD, command prompts. Yes, D column is D drive. That to take D drive. In D drive, they say test folder, CD test folder, DER. Sorry, CLS, D drive. Yes, D colon, CD backslash, D drive. See D drive, in D drive here, mn Python folder. Yes, DER, I can see this folder. mnref Python folder. This is a folder. This is a folder. Okay. cd change of directory. Change of directory. Yes. mnref Python folder. Yes, changed. cls dir. Okay. See that. Okay, dir. Okay. Fine. Yes. Now here Python folder. In this they say test.py. Here this is some test.py file here. Yes, notepad. Yes, notepad. Test.py. Notepad test.py. Then Python script. Notepad. This is Python. Some Python script. See here a equal to 10, a equal to 10, b equal to 20, c equal to a plus b. So first print addition, c equal to a minus b, subtraction, c equal to a into b, then multiplication, right? This is a code. Okay. Yes, Python is a interpreter based language. Python is a interpreter based language. Python is a interpreter based language. Yes, how it's working here. Let us see. Python is an interpreter based language. See, it's notepad test.py. So this is notepad. Okay. After developing program in notepad here, notepad. Okay. Yes. Next here, submitting to run it here. Python script submitting here. Python. Yes, Python interpreter. Yes. See this. Directly is working. Yes, here. Yes, without checking any errors, directly is working. Directly submitted running here. Simply Python code running. Suppose C program. Let us take C program. If it is C program, you have to compile it, right? Yes, I think in C language, you have compiled, right? Alt C compilation, something like this. Compilation running program, right? In C program, first of all, you have to compile it. Yes, all the errors. If no errors, then executing. Yes, here don't have that kind of compilation process. Compilation means checking for errors. Compilation means checking for errors. But here in Python script, directly submitting, no checking for errors. The directly submission here. Directly submission here. So interpreter taking your source code. This is called a source code. Yes, this program. Yes, this program is a source code. This is Python source code. Python source code. Next, this is Java source code. This program. So our programs. So what are the programs we are writing? Yes, our programs called as source code. This is source code. Java source code. This is Java source code. This is next HTML source code. This is called as source code. This is called as source. It's a source code. Okay, it's a source code, right? It's a source code. Okay, so interpreter source code test.py. That Python script. Python script. See the code directly submitting. Directly submitting. Python directly submitting it. Directly submitted and running. Okay. Yes, suppose for example here, for example, some scenario. Suppose here, yes, comma missing some comma. What happens? See here, interpreter first of all checking for first statement. First statement is correct, it executes. Next statement correct, executes. See, execution of first statement means a equal 10 means it allocates memory for A and storing 10. Memory allocating for B, then storing 20. Next, it performs these calculations. C equal to A plus B. Yes. So this statement completed. This statement completed. This statement completed. After that, not checking for this statement. Yes, something wrong here. Simply stops. That's it. Okay. Suppose if it is compiled, whatever, first checking for all errors. If no errors, then execution starts. But interpreter is different here. Yes. Let us discuss very clearly. Now this is the interpreter. Interpreter here. Now, yes, let us save this one here. Save that. Saved. Yes, something mistake. Something mistake. Let us save it. Saved. After saving, now let us run it. Let us, yes, Python. Let us run it. Yes, error message. Okay, error message. Error message. So what is happening? What is happening? Now in this program, what is happening? Let us. Yes, what is happening in this program? Yes, what is happening here? Let us see. What is happening here? What is happening? Yes, interpreter. How it's working? Yes, let me explain very clearly. Very clearly. Yes. Yes. Suppose this is some Python code. Python code. Okay, Python code. Yes, first statement. Yeah, this Python code. this Python code, this Python code, this code, this code, this code. Okay. Yes. So this code, first statement. Yes. Next statement. Yes. Next statement. Like there are some statements. Yes. In Python, every line is a statement. Okay. Next, one more thing. Python semicolon not necessary, optional. Java semicolon required. C language semicolon required. C++ semicolon required. But in Python, semicolon is but optional. Yes, in Python, semicolon is optional. It's not necessary. Okay. Suppose there are some statements like this. There are some statements. Okay. Now, yes, interpreter. How interpreter working on this? Interpreter directly working on the source code. Interpreter takes the source code and executes directly. How it executes? Let us see. How it's working. Interpreter, how it's working. So first of all, interpreter checks for the first statement. So first statement is correct. First statement is correct. Syntax is correct. Syntax means some rules. Syntax means some rules. Rules. See, every language having its own syntax and some rules. So Python, print open brackets, close brackets, open double quote, close double. That's rule. Next here, comma required. Expecting for comma. There are some rules here. Like this about Java. Suppose Java program. Suppose Java. Here are some rules. See, open brace. Yes, here again, close brace. Yes, here open, close. Next main. So open bracket, close bracket. Yes, here open bracket, close bracket. Some semicolon, something like this. There are some rules. Nothing but syntax. Rules. Language rules. Language syntax. Okay. Yes. So here first. So first of all, yes. So checking for the first statement. Checking for the first statement. If first statement is correct, interpreter checks for the first statement. If statement is correct here, yes, immediately it converts into binary code. That first statement converts into binary format. Binary format and given to processor. Just given to processor. So processor taking that code here, generating output. So immediately getting output. Immediately getting output. Over. See here, 1 second. See, next coming statements may be right or wrong. Interpreter never think about next coming statements. Next coming statements may be right or wrong. Yes, next coming statements. Next coming statements may be right or wrong. Interpreter never think about next coming statements. Interpreter never think about next statements here. Yes, if the statement is correct, if statement is correct here, immediately converts into binary code, then given to processor, generating output. So first statement completed. Checking completed and execution completed. So got the output also. Checking completed and execution also completed. Yes, after that, go to next statement. Checking for next statement. Checking for next statement. Suppose next statement also correct. Same next statement also correct. Okay, next statement also correct here. Simply converts into binary code. Same converts into binary code. Just give it to processor here. Give it to processor and generating outputs. Generating outputs. Generating outputs. After that, checking for next statements. Checking for next statements. Okay. Suppose something wrong here, stops. Something like simply stops. Okay. So how this interpreter is working here? Line by line. Checking first line and executing immediately. Means first line is over. Completed. Checking for second line. Yes, correct. Then execution. So completed. Second line also completed. No third line. Something wrong here. Third line, something wrong, simply stops. Any error comes, simply stops. Any error is there, simply stops. This is working of interpreter, right? Yes. Compiler. If it is compiler, how it works? Let us take compiler here. Yes. Let us see compiler. How compiler is working? Okay. Compiler. Yes, compiler. Yes, compiler source code. Suppose C program. C is a compiler based language. C is a compiler based. Yes, if it is compiler, how it's working here? Compiler. See, compiler checking for the first statement. Compiler. Yes, compiler checking for the first statement. Suppose first statement is correct. First statement is correct. Even it's correct here, it won't convert into binary code. No, it won't convert. It won't convert into binary code. Then checking for second statement. Even correct, it won't convert. It won't convert. It won't convert into binary code. It won't convert. Okay. Checking first statement. If it is correct, then go to second statement. If it is correct, then go to third statement. Suppose something is wrong. Something is wrong. Error at third line. Error at third line. error at third line. After that, checking for next statements. Suppose next statement also correct. Next statement also correct. Then checking for next statements. Suppose next statement also correct. Next statement also correct. Checking for next statements. Suppose something wrong here. Something wrong. Something wrong. It shows error at some line. It shows error at some line. After that, next statement. Yes, correct. Okay. Yes, next statement. Checking for next statement. Correct. And then checking for next statement. Checking for next statement. Okay. Suppose something wrong here. Okay. So what happens here? Compiler checks whole program from top to bottom. Compiler checks the whole program from top to bottom and shows all the errors. Okay. 1 second. Let me have some water. Yes, compiler checking whole program. Compiler checking whole program from top to bottom. It checks the whole program from top to bottom and shows all the errors. See, in case of interpreter, what happens here? Any error comes, simply stops. Means it shows only one error. Interpreter shows only one error. But when come to compiler here, it shows all the errors. Compiler shows all the errors from top to bottom. All the errors. Okay. A stolen error. Maybe next line. Next line. Top to bottom shows all the errors. Okay. After that, you have to correct the mistakes. As a programmer, correcting mistakes. Okay. After correcting mistakes here, next you have to recompile. Recompilation. Suppose next time no error. Next time no error here. Yes, suppose next time here also fine. Everything is fine. Top to bottom. Next time everything is fine. Top to bottom. Everything is fine. What happens here? Everything is fine. No errors. If no errors here, then compiler it opens another file. It opens one more file. Just opening another file. Just it opens another file. See test.c. This is your C program. C program source code. Test.c. Test.c program, right? Yes, compiling test.c program top to bottom. Compiling from top to bottom. Yes, if no errors here, yes, then it opens another file. Just opening another file. If no errors, compiler opens another file. Opening this file here, then whole code converts into binary format. Every statement converts into binary format. First statement, binary format. Next statement, binary format. So every statement converts into binary format. Binary code. Every statement converts into binary format. I'm right to this side. Yes, every statement converts into binary format. Every statement converts into binary format and write to another file. Yes, write to this file. Yes, this file is called as exe file. Yes, exe file. Okay, exe file means executable file. Ready to execute. This is ready to execute. Okay. Now this exe file submitted to processor. So processor taking exe file and executing at a time, generating output. Okay. So here, so compiler checking whole program from top to bottom. Here. Whole program from top to bottom. If no errors, generating one exe file. Now this exe file is submitted to processor. So processor will execute exe file, generating all this output at a time. So this is working of compiler. Yes, let me show practical explanation how compiler is working. Yes, this is very, very important for us. So next we are going to discuss about independent platform. Okay, to understand independent platform, that exe file knowledge is very, very important topic here. So for that reason I am explaining about exe file. Okay, yes, definitely. Yes, in interviews may be asking some question. What is exe file? Why exe file is, yes, platform dependent? Why exe file is OS dependent? May be asking this question. Next, what is Java .class file? Yes, how it is independent platform? Can you explain the difference between exe file .class file? The differences. Okay. Yes. See, to explain about independent platform. Yes, to explain about independent platform here. Yes, you should explain about exe file .class file, that comparison. After comparison, finally you have to present Java independent platform. Yes, that same topic we'll discuss now. Same topic. Now I'm explaining here. Okay. Yes. So interpreter, okay. Now compiler. Let us see. Compiler. Yeah, this is Linux base. This is Linux base. Okay, Ubuntu Linux. Linux base. ls 1 second. cd mnref folder. mnref. Yes. Present working directory mnref ls. Okay, fine. Yes, present working directory mnref ls. Yes, remove star. All the files are removed. Present working directory mnref. Yes, mnref ls. In this nothing is there. Now same Python script. Yes, addition, subtraction, and multiplication. Same thing, just I'm writing in C language. gedit test.c program. gedit test.c program. Hash include stdio.h. Okay. Yes, next wide main function. Okay. Yes, in Linux, convert.h header file not necessary. Okay, Linux don't, you see ANSYS. Yes, Turbo C is different, ANSYS is different. It's ANSYS. Turbo C for learning purpose. Turbo C for learning purpose. ANSYS real-time application development. This is ANSYS using for real-time application development. Okay, yes, main function. In main function, suppose int a equal to 10 digits. Okay, next int b. Yes, int b. Int b is equal to 20. Okay, yes, after this next int c gets half declaration. C is equal to here a plus b. A plus b here. Next printf. Yes, printf. Yes, addition. Yes, addition is equal to %d. Yes, slash n means take to next line here, comma c, displaying c value. Okay, the result value c equal to a plus b. Okay, yes, next after this, next c equal to a minus b, c equal to a minus b. Yes, here's a subtraction. Yes, subtraction is equal to c. Okay, next c equal to, yes, a into b. A into b here, multiplication. Yes, multiplication. Yes, multiplication. Yes, multiplication. Yes, is equal to this. So a value 10, b value 20, int c, that result variable c equal to a plus c. So first is string addition. Yes, next. Yes, minus. Yes, subtraction is string here. Okay, minus. Next c equal to a into b. After that, multiplication. Okay. Control yes, save. It's like notepad. It's notepad. Notepad. Yes, this ls series. Test.c program. Test.c file. Test.c program, right? It's a C program. Okay. Now I'm compiling this program. cc-c. Yes, 1 second. GCC that is, yes, C++ compiler. GCC is a C++ compiler. GCC C++. CC, it's a C language compiler. cc-c test.c, right? Yes, compiled one .2 file generated. Yes, .2 means object file. That object file contains binary codes. Now this object file, so next step you have to convert into exe formats. Suppose project exe. Exe means project. Just that one. Right? Yes. ls. See this? The project exe file created. The green color is exe file. Then finally we got exe file. Now this exe file executing, right? Project exe file. Yes, execute it. That's it. Okay. So what is happening here? First step, program compiles. After compilation, no errors. If no errors, next convert into exe file. If no errors, now convert into exe file. That project exe file got it. After getting exe file here, next running that exe file, what the results? That's it. So what is happening here? Compiler checking program from top to bottom. If no errors, converting into exe file. Finally, exe file executing. Okay. Yes. Suppose let us make some mistakes here. There are some mistakes in program. Some mistakes. Suppose here semicolon missing. Okay. Suppose here double quotation missing. Okay. Suppose here some comma missing. Okay. Suppose here this semicolon is maybe bracket is missing here. There are some mistakes. Save. Control yes. Save it. Yes. After saving here. Now let us compile it. cc yes -c test.c, test.c compiling. 1 second. No compiling. cc-c test.c. See this? All that list of errors from top to bottom, right? See, if it is a interpreter multiplies only one error, interpreter any error comes simply stops. Simply stops. It won't go for next statements. If any error comes, interpreter stops. But compiled is not like that. Checking all the errors. See, error at 9th line, error at 11th line, error at 13th. See this 9, line number 9, line number 11, line number 13, yes, line number 23. Yes, all the errors. Compiler shows all the errors from top to bottom. Compiler shows all the errors from top to bottom. Now, yes, correct all these errors. Just the correction of errors. Just I'm correcting errors. Yes, here 9th line. Yes, line number 7. So here 9th line. So here before that. Here this mistake. Yes, next here. Yes, 13th line error. 13th line. Yes, at the bottom line number is there. Okay, 13th line. Save. Save it. And let us recompile again here. Let us recompile. Recompile. cc-c. Still errors. Yes, 70th line error. 21 line error. So 23rd line error here. Okay. Yes, again. Let us again. Yes, again here. 70th line. Here 70th line error. So this is missing here. Okay. Yes, next 70th line error here. Next 21 line error. This error, right? Save. Save. Yes, after saving here. No, recompile. Yes, no errors. No errors. No errors. Yes, if no error, next we should convert into yes exe format. If no error, convert into exe format. That convert into exe format. This is test.o. If no error getting yes, 1 second. 1 second. Ls yes, remove the project exe. Yes, remove start.o. I'll remove ls. See, only test.c file is there. Only test.c file. Now cc -c test.c. Yes, compiled. After compilation ls, now we got test.o file. Result file test.o. Now this test.o file we should convert into exe format. Yes, exe format. It's a final building C language. Test.o. Test.o. Yes, exe file got it. Run it. Now project exe file got it. Project exe file got it. Okay, this project exe file we should run it. Yes, right. Yes, we got the output. Addition, subtraction, multiplication. Addition, subtraction, multiplication. So finally we got the output, right? So what is happening here? What is happening here? Compiler, how it's working here? Compiler checking. Yes, compiler checking code from top to bottom. Source code test.c. The test.c code checking from top to bottom. Checking from top to bottom. If no errors, generating one exe file. Yes, let me show that exe file. Yeah, gedit the project exe file. Yes, opening that project exe file. Yes, it's opening project exe file. Exe file is a binary code file, binary format. Yes, see this binary. It's a machine language. 0s1s format. It's a machine language. Okay. Yes, it's a binary code. Just it's a binary code. Yes, we can't understand this code. It's a machine language. It's a system understandable language. 0s1s format. It's a binary code. It's a binary code. Okay. So here, so what is happening here? Compiler checking whole code from top to bottom. If no errors, generating one exe file. That project exe, right? Generated one exe. Project exe. Yes. Next, submit it to processor. Now processor taking that exe file and executing, generating output. Finally getting output. This is difference between interpreter and compiler. Difference between interpreter and compiler. Yes, let me explain points wise here. Let us have a discussion, points wise discussion for better understanding. It's points wise. The differences. Interpreter versus compiler, the differences. The differences. Yes, interpreter. Interpreter. Yes, interpreter. Yes, versus compiler. Interpreter and compiler. Interpreter and compiler. What's the difference? Let us see the differences. See first difference. First difference, interpreter. Yes. Yes, it checks the code. It checks the code. So our program that is called code. code, it checks the code line by line, line by line. It checks the code line by line. Okay. So interpreter checks the code line by line. Interpreter checks the code line by line. Yes. Compiler. Yes. Whole program from top to bottom. Whole whole code from top to bottom, top to bottom, top to bottom, top to bottom. But checking whole code. Okay. See, interpreter checks the code line by line. Interpreter checking first line if it is correct, generating output. Second line if it is correct, generating output. Third line correct, generating output. Something wrong, simply stops. Okay, but compiler is not like that here. Compiler checking whole code. Compiler checking whole code from top to bottom. Okay. Yes. Next. Yes. It generates output. Interpreter generates output line by line. Yes, line by line. Interpreter generates output line by line. Just it's line by line. So output generating line by line. So interpreter, it generates output line by line. It generates output line by line. Yes, in case of compiler, what happens? Compiler, whole code checking, if no errors, generating one exe file. That exe file at a time executing, giving output, right? So this is at a time output here. So at a time, yes, at a time output, at a time output. So at once, at a time output, at a time output. Okay, so at a time giving output, right? Yes, next difference. Yes, interpreter, it shows only one error. It shows only one error. Yes, interpreter shows only one error. If any error comes, interpreter stops. If any error comes, interpreter stops. Means it shows only one error. Interpreter shows only one error. Okay, if any error comes, interpreter stops. It shows only one error. Yes, when compile here, yes, it shows all the errors. It shows all the errors. Yes, all the errors from top to bottom. Same thing. Yes, already discussed, right? From top to bottom. Okay. Yes, same thing explained practically here. It shows all the errors. Compiler shows all the errors from top to bottom. It's practically showed. Okay. Yes, next. Most important difference is exe file. Important difference. Main difference between interpreter and compiler is exe file. Yes, it does not generate exe file. Yes, it does not generate exe file. Yes, it generates exe file. Generates exe file. Yes, interpreter never generating exe file. But compiler generates exe file. This is main difference. So what's the main difference between interpreter and compiler? Exe file is the main difference. Okay. See, when you facing interview here, interpreter compiler difference, immediate first answer is exe file. Interpreter does not generate exe file. Compiler generates exe file. That's the main difference. Next, other difference also you can explain. Other differences. But main point, primary point is this is primary difference is this. Okay, interpreter does not generate exe file. Compiler generates exe file. Interpreter does not generate exe. Compiler generates exe file. The main difference. Next, see, in case of interpreter, what is happening here? See, notepad. Just let us correct these errors. Just correction error. Just after correcting error here, see, submitting. Yes, Python the script, right? Submitted. Directly executed. That interpreter directly executed. Source code executed directly here. See, it executes source code directly here. It executes source code directly. Yes, source code directly here. It executes source code directly here. Just executing source code directly. It executes source code directly. But compiler what happens here? It executes exe, not source code. It generates one exe file. That exe file executes. It executes exe file. It executes exe file, not source code here. So compiler converts your program to exe format, then executing. But interpreter directly executes. So interpreter, it executes source code directly here. Compiler exe file executes. It executes exe file. Correct? Yes. Next difference. See, interpreter based languages or scripting language. Yes, these are examples of scripting languages. Okay. Yes, these scripting languages. Yes, scripting languages. Scripting languages are interpreter based or interpreter based. Interpreter based. Okay. Yes, interpreter. All scripting languages are interpreter based languages. Scripting languages. Scripting means anytime you can modify. Yeah, that also I'll show. Scripting means that can be modified anytime here. The scripting means that can be modified anytime here. Okay. Yes, scripting languages are interpreter based. Yes, they are programming languages. Programming languages. Programming languages. Programming language. They are called as programming languages. Okay. For this section, programming languages. Okay. Yes, so programming languages are compiler based. These are scripting languages. These are yes, scripting language and program language. Okay. Yes, for this example, yes, scripting language examples. HTML is a scripting language. Yes, next Python is a scripting language. Next PHP is a scripting language. Perl scripting language. Next in Linux this is shell scripting. Shell scripting. Next JavaScript. These all are scripting language. Programming languages for this example. Programming languages example C language. Yes, C++. Next .NET C#. These are scripting and programming. What is Java? Is it compiler or interpreter? We'll see next page. That is the actual point we should discuss. We'll discuss page. Okay. Now here, so these are scripting languages: HTML, Python. Yes, HTML, hypertext markup language. For HTML, see, HTML is a browser understandable language. HTML is a browser understandable language. Yes, for HTML, browser is an interpreter. HTML, browser is an interpreter. Browser is an interpreter for the HTML. For Python is having its own interpreter. Python interpreter. Okay, PHP interpreter. Perl interpreter here. Shell is an interpreter. In Linux, shell is an interpreter. JavaScript. For JavaScript also browser. JavaScript also browser. Browser understandable language. Browser is interpreter. Next, these are the compilers. C language compiler, C++ compiler, or .NET compiler. What is Java? We'll see. Wait. Okay. Yes. Next here, in case of interpreter based language, yes, that code can be modified anytime. This code can be modified anytime here. Okay. So open this. Suppose I don't want some functionality. I don't want this. Remove this. Remove. Save and exit. Yes. And yes. Anytime you can modify. Anytime. Yes. Again I want. Yes. Again I want that functionality here. Yes. In here. Okay. Writing that, adding that code and execute it. Anytime you can modify. Means it's a open source. Open source. Scripting is an open source. Anytime it can be modified. Okay. Yes. It is an open source. It's an open source. It's an open source. Okay. Python script is an open source that can be modified anytime. Yes, it's open source that can be modified anytime. Yes, JavaScript, shell scripting, PHP, yes, HTML, all are open source. Anytime that can be modified here. Anytime that can be modified. So, for example, let us take HTML here. HTML, see HTML. This is test.html. Yes, I'm running that. Double click running. See username, password. Submit, reset, right? Okay. Yes. Username something, password, reset to initial value. We can find. Yes, now here. Right click. Yes, open with Notepad. Yes, in this. Suppose I don't want reset button. Just remove reset button. Control yes. Save it, and run it. Double click, run it. Yes. Reset button remote. Okay, reset button remote, right? Yes. Again I want reset button. Right click. Yes, open with yes Notepad. Now add the reset button here. Placing reset button. Save and exit. Here. Double click on it. Yes. Now reset button again. It's appearing, right? So means anytime you can modify. This can be modified anytime. So it's a open source. So it's a open source. Yes, it can be modified. At any time. You can modify it. Yes, compile based. If it is compile based here, yes, you cannot modify. See, compile based exe file, right? Exe file you can't modify. We can't modify exe file. Okay, that exe file you can't modify. Okay, see exe file. Open that exe file. Just all the binary codes. It's a binary code. Just it's a binary format. Yes, we can't modify. Even we don't know about that. We can't understand. How can you modify? We can't. Yes, we can't modify this. Okay, exe format we can't modify. Okay, really, if you want to modify, yes, you have to rebuild the whole application. Rebuild means modify the C program. Yes, after compile it, generate some binary code, next convert into exe format. So for real-time project, many files. If you want to modify any code here, yes, complete project you have to recompile and recreate exe file. Means you can't modify directly. No code modification facility, right? So it's not open source. Compile based programming language. Programming language is not open source. They are not open source. Yes, not an open source. Not an open source. It's not an open source. Right? Yes. Next, one more most important difference. Okay. Yes, most important difference here. Yes, interpreter. Yes, interpreter. Interpreter based languages. Interpreter based languages. Yes, don't have exe files. Simple points. Don't have exe file. Yes, compile based. Everything is exe file. Everything is an exe. Here, everything is exe file. Everything is an exe file. Yes, everything is an exe file here. Okay. See, interpreter based language don't have exe file. See, interpreter based language Python. Yes, the test.py file executing directly. No exe file. Directly we are executing. Yes, suppose for example HTML file that executing directly here. Okay, so HTML, Python, Linux shell scripting, Linux shell scripting. Yes, shell script don't have any scripts. Okay, 1 second. Yes, you don't have any script. Believe it. Yes, even Linux scripting also here. It's open source anytime. Yes, no HTML.sh shell script, no exe format for that. So this is difference between interpreter and compiler. Yes, interpreter it checks the code line by line. Yes, compiler whole program at a time here, checking from top to bottom. Okay. Yes, interpreter line by line outputs. Interpret compile at a time because exe file at a time getting output here. Yes, interpreter shows only one error, but compile is all errors from top to bottom. Yes, main difference is this exe file. Interpreter does not generate exe file. Compiler generates exe file. Yes, see for interpreter based language don't have the exe file. Interpreter based language don't have exe file. Yes, in compiler based everything is exe file. Okay. Yes, interpreter based all scripting languages. Scripting languages are interpreter based. Programming languages are compiler based. Okay. Yes, interpreter based examples. Compiler based examples. Now, what is Java? What is Java? Yes, Java. What is Java here? Yes, Java. Yes, is it interpreter based or compiler based? Let us see. So let me explain about this. After that, you decide it. I'll explain about Java. Okay. Yes, I'll explain about Java. After explaining, just you decide it. Okay, now we decide it here. Now we can decide it here. Java based on what here? Is it interpreter based or compiler based? Okay, let me finish explanation. Then you decide it. I'm leaving for that answer. I'm leaving for your answer. Okay, just I'll explain now. Yes, yes, Sahana saying that compiler. Okay, let me explain. After explanation, just you answer the question. Okay, first let me explain. So what is Java? Yes, see, except Java, see in other languages, what happens here in other languages? Yes, except Java, in other languages like C language, C++, something like this, maybe HTML, maybe Python, except Java, in other languages here, source code means your program code. Source code directly converts into binary code. Source code directly converts into binary code. This binary code is given to processor. So processor taking that code, generating output simply. That's it. Source code to binary code directly. Suppose Python, in Python interpreter converts source code to binary codes, then executing. Suppose C language, compiler converts source code to binary code. C language, compiler converts. Okay. Suppose HTML interpreter. So here any language, either interpreter or compiler, converts source code to binary codes. Only one step. Source code, your program code directly converts into binary codes and submitted to processor generating outputs. Yes, in Java, what happens here? Let us go to Java. In Java, what happens here? Java, first source code. This is source code. Yes, source code converts into bytecode first of all. So bytecode converts into binary code. This binary code given to processor. Okay, right? That's submit to processor, generating final output. Okay, so you can except Java only one step. Except Java only one step. But when come to Java, there are two steps here. First step is source code to bytecode. Second step is bytecode to binary code. Yes, in Java, yeah, there's a intermediate code introduced here. Bytecode, some intermediate codes. Why this is? To make the Java as independent of platform. Bytecodes was introduced here. See, why bytecode introduced in Java? Reason to make the Java as independent of platform. Okay, question is here. Question is why bytecode introduced in Java? To make it as Java independent platform. Okay. Yes, source code. So converts into bytecode here. So bytecode converts into binary code, then finally execution. Okay, right? Yes. Source code to bytecode. Who will convert this? Source code to bytecode. Yes. This is by the compiler. So this is by the compiler. Okay. So by the Java compiler. Okay. See, Java compiler checks the errors. All the errors checking by the Java compiler. Yes, all the errors checking by the Java compiler. In Java programming, errors checking by the compiler. If no errors, generating bytecode file. After generating bytecode here, yes, this bytecode converts into binary code. Who will do this? Bytecode converting into binary code here. Yes, who will do this here? You say by the interpreter. So interpreter. Okay. So interpreter. Okay. So your bytecode converts into binary code by the Java interpreter. So Java interpreter. Yes, interpreter. Okay. Yes. So bytecode converts into binary code by the interpreter. Right? After converting to binary code here, given to processor finally here. The binary code. After getting binary code here, this binary code simply given to processor. So processor taking that code and finally generating output. So what is happening here? First is source code. Suppose test.java is a source file. Source code, right? Yeah, this will be given to Java C compiler. So this is compiler. Java C means compiler. It's a compiler. Just a compiler. Okay. Yes. Test.java. The test.java. See, first test.java given to Java C compiler. Java C means Java compiler. So Java compiler taking that test.java. If no errors, generating bytecode. It generates bytecode means test.class file generates. So dot class file contains bytecode. Exe file contains binary codes. Yes, the differences will discuss. What is exe file? What is dot class file? That also will discuss. Wait. Okay. Yes. Now source code given to compiler here. Java compiler checking errors from top to bottom. If no errors, generating one bytecode file test.class file. After generating test.class file, now it's a bytecode, right? Yes, bytecode. Yes. So bytecode then bytecode, test dot class file. So test dot class file. Now this test dot class file, yes, this is given to Java interpreter. Yes, interpreter. Yes, interpreter. Yes, interpreter. Yes, given interpreter. Yes, interpreter is a part of JVM. Yes, JVM different, Java compile is different. Java compile is not a part of JVM. JVM is Java virtual machine. Yes, about JVM we'll discuss separately. Yes, I will take separate class on JVM. Yes, we'll discuss very clearly. Even JVM internals also I'll explain. Yes, in JVM, behind of JVM C program running and C++. C and C++ programs will run here. So how that C and C++ working behind of JVM, that also I'll explain. Practically I'll show. Practically I'll show how that C and C++ working behind of JVM. Practically I'll show. Okay. Yes. Now bytecode tested dot class file given to interpreter, Java interpreter. Now interpreter converts that code into binary code line by line. First line converted into binary codes and given to processor line by line. See here, it compiled them top to bottom compilation and generating one dot class file. Now this dot class file executing line by line, not at a time here. Dot class file executing line by line, line by line. Dot class executing by the interpreter line by line. First line converts into binary codes and given to processor. So first line completed. Next second line. Interpreter taking second line here. That second line converted into binary codes. Again giving to processor. Okay. Again to the processor, right? Yes. Again given to processor. Next third line converts into binary codes. Binary code just given to processor. Just given to processor like this. So line by line finally executing line by line. So getting output that. Okay. Yes. So what is happening here? Yes, in Java, errors checking by the compiler, errors checking. Yes, errors checking by the compiler, errors checking. Yes, errors checking by the compiler, 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 errors checking by the compiler. Okay. Yes, next runtime. Runtime is execution. Runtime. Okay. Yes, runtime. Yes, runtime execution. Yes, runtime execution. Execution by the interpreter. Execution by the interpreter. Execution by the interpreter. Right? Interpreter. Okay. Yes. Execution by the interpreter. Right? Yes. See, errors checking by the compiler here. Errors checking by the compiler. If no errors, then generating one dot class file. The dot class file given to interpreter. So interpreter executes and giving output finally here. Now, tell me, Java depends on what? Is it compiler based or interpreter based? See, errors checking by the compiler. If no errors, then program execution by the interpreter. So both are involving here, compiler and interpreter. Now tell me, yes, your answer. Now I'm expecting answer from you guys. Now Java depending on what? Is it compiler or interpreter? Is it compiler or interpreter? Yes, depending on both. Yes, it depends on both. Yes, it depends. Yes, it depends on both. Depends on both. Java depends on both here. So Java, yes, interpreter as well as compiler based. Java is a compiler as well as interpreter based language. Java is a compiler as well as interpreter based. Java is a compiler as well as interpreter based. That is, yes, some idea in Java. So compiler based on both here. Compiler based on interpreter as well as compiler. So yeah, Java based on both compiler interpreter. Errors taken by the compiler, runtime by the interpreter. Fine. Next, one more question for you guys. See, Java depending on both. Fine. Now one more question. Try to understand this point here. Yes, last point. Interpreter based language don't have exe file. Last point. The ninth point. Interpreter based language don't have exe file. One second. See, any language runtime means program execution time. Any language runtime is an interpreter based. Interpreter based. No exe file. Any language runtime is interpreter based. If language is interpreter based, means your program executing by the interpreter. If program executing runtime by the interpreter, no exe file. See Python program executing by the interpreter, no exe file. Next HTML executing by the interpreter, no exe file. So next is shell scripting executing by the interpreter, no exe file. So any language runtime, see any language runtime, see that point. Any language runtime is an interpreter based, no exe file, no exe file, no exe file. Okay, now come to Java. Java runtime. Java runtime is a interpreter based, not compiler. Java runtime is interpreter based. Okay, Java runtime is a interpreter based. Okay, Java runtime is interpreter. Try to understand this point here. Try to understand here. Some question you have to answer. Yes, any language runtime is an interpreter based, no exe file. Any language, yes, runtime is interpreter based, no exe file, Not Java. Java runtime is a interpreter based. No question is, yes. Can we create question is, can we create exe file in Java? That is the question, interview question. Or another way, same question asking another way. Yes, is there any exe file concept in Java? Exe file concept in Java. Say yes or no. Answer is yes or no. Okay, yes. So can we create exe file in Java? Is there any exe file concept in Java? Say yes or no. See, I'm repeating topic once again. That's what I said already. Told you. Yes, please remember this point here. Try to understand this point here. Okay, some guys are giving correct answers, some guys are wrong answers giving here. Wrong answers. See, I'm repeating once again. Any language runtime is interpreter based. If runtime is interpreter based, no exe file. If runtime is interpreter based, no exe file. Java runtime is interpreter based. No question is there an exe file concept in Java, or can we create exe file in Java? Answer is yes or no. Tell me. Yes, yeah, okay, fine. Corrected your output. Okay, good, well and good. Yes. See, Java runtime is interpreter based. Since it's interpreter based, no exe file concept in Java. Yes, answer is no. This is compulsory question, interview question. Yes, in Java everything is dot class file. Java everything. Yes, no exe file in Java here. In Java everything is a dot class file. Everything is a dot class file. Yes, everything is dot class file. So what is dot class file? What is dot exe file? See, dot exe file is a already prepared file, but dot class file is not a prepared file. Okay. Yes, dot class always preparing at runtime. Exe file is already prepared file. Exe file is already prepared for specific OS, but dot class is not a prepared file. Dot class file after moving to OS then prepare starts. Yes, we'll discuss. The topic is independent of that. Now you can understand very clearly independent of that. Okay. Now you can understand very clearly what is independent of platform. Now you can understand because yes, Java about interpreter compiler expand. How exe file is generating expand. Okay, now you can understand how interpreter working, how compiler working. Next OS, how OS is working. That point also discussed. About OS discussed, about exe file discussed, about interpreter discussed, about compiler discussed. Now you can understand independent platform portability. Okay, that features. Yes, now you can understand clearly. Yes. See this today topic, difference between interpreter and compiler. Okay. Yes. See, Java depends on both compiler as well as interpreter. Yes, how? See that. Java errors checking by the compiler. If no errors, Java compiler generates one dot class file. Dot class file is a bytecode file. A Java runtime by the interpreter. Okay. See, source codes given to Java compiler, bytecodes, like this, all the same what we discussed. source code to bytecode, so binary code. Okay, there are two steps in this. Two steps. Source code to bytecode by the compiler, bytecode to binary code by the interpreter. So Java depending on both the compiler as interpreter. Okay, Java runtime is interpreter based. So any language runtime is interpreter based, no exe file. Yes, since Java runtime is interpreter based, no exe file concept in Java. No exe file concept in Java. Okay, question is, can we create exe file in Java? No. No. There is no concept of exe file in Java. Yes, in Java, everything is dot class file. But dot class file is not exe file. Exe file is different. Dot class file is different. Yes, the topic also you have to discuss. So what's the difference between .exe, .class file? Differences. Next, independent of platform, portability, these things. Okay, for this, yes, tomorrow, yes, I'll clear this. Yes, tomorrow class, whole class is enough here. Okay, so tomorrow class, I'll clear all that features here. Now we can understand these features very clearly. Okay, to understand these features, yesterday's class, today's class is a prerequisite. Yesterday's class, today's class is a prerequisite to understand these features. Otherwise, you can't understand. Okay, yes. Now this topic, tomorrow will continue. Tomorrow, I'll be finishing these features. After that, just how to set up Java. Okay, next Eclipse, the setups I'll explain. Yes, that's all for today. Yes, let us wind up session for today. Enough for today. Yes, tomorrow we'll go to new topic. Yes, features, Java features we'll discuss. Okay. Yes, 1 second. This question. Yes, 1 second. 1 second. Some question. Java dot class will create rather than exe. Yes. Java creating dot class, not exe file. Suppose if it is exe file, that is OS dependent. Okay. So why dot class file concept introduced in Java to make it as independent platform? Dot class file is independent platform. Okay. Dot exe file is OS dependent. Okay. Dot exe file is OS dependent. To make the Java as independent platform, the dot class file was introduced. Okay. Yes. How exe is working, how dot class file is working, we should discuss tomorrow topic. In tomorrow topic, how exe is working internally, how dot class file is working internally, those topics we'll discuss. Okay. Yes, even that also practically also, like today topic, practically also how dot class is working here, how it's working, how exe file is working internally. Okay. Dot class working with OS, how dot class is working with OS, how exe file is working with OS. Okay, so every program executing with OS, right? Yes, how OS will execute dot class file. Next, how OS file executing exe file. That topic. Dot class executing by the OS. Yes, dot exe executing by the OS. How OS will execute, how OS will run dot class file and exe file. That also practically. So that practically tomorrow we'll discuss. Okay. So tomorrow, of course, almost the features finishing and Java setup will be starting. Yeah, that's all for today. Yes, any doubts? Yes, you guys understanding my classes clearly? Yes, are you understanding my classes? Are you feeling any fast? Are you feeling any fast? Yes, topic is very clear, right? Yes, no fast, right? I think this base is okay. See, 1 second. Going forward, once programming starts, I'll go very slowly. In programming, step by step, line by line, I have to explain. Yes, almost 300 examples will be discussing. Okay. Yes, almost. Yes. No, not on notepad here. See, application development, sometimes you can use notepad, sometimes you can use IDE also. Yes, not on notepad here. In IDE also interpreter working. Okay. In Eclipse IDE, compiler working, sometimes interpreter working. Okay, not on notepads. Suppose Python. In Python, they say PyCharm. Yes, PyCharm IDE. See, here I'm using Python also. Yes, with the big data applications. Yes, PyCharm. In PyCharm, it's IDE. Okay, in IDE also interpreter work. Not notepad. Don't think notepad here. Not a notepad here. In IDE also. Yes, Eclipse IDE, PyCharm IDE. Okay, in IDE also interpreter work. Okay, right? Yeah, definitely. Yes, many, not one program, many examples. Okay, many examples, practical examples, real-time examples I'll explain. Many examples I'll explain. Yes, around 300 programs will be explaining. Okay, how interpreter working, how oops working, and everything practically I'll explain. Okay, oops not started here. Don't worry, practically I'll explain. Okay, yes, yes, I'm sure I'll explain more than the industry. No trainer will cover that much of topics. Even my way of explanation is different from others. Okay, no one can reach my standards. Yes, in industry here, no trainer reaching my standards. Even websites also. Yes, even websites also. No website will reach my standards. Yes, my knowledge, my experience is more than the industry. Even in Google also, you can't see certain kind of things. That is my experience. Okay. Yes, I'll explain very clearly. Don't worry. Yes, going forward, you'll see. Yes, what is my experience? Yes, the way of presentation. You'll see going forward. See, anyone covering more than my topics, just you let me know. I'll cover it. Okay, anyone, any trainer, any website covering more than our syllabus, just you let me know. I'll explain very clear the topic also. Right? Okay. Yeah. So thank you guys. Thank you. Yes. See you tomorrow. Have a great night. See you tomorrow.